Hey everyone, I'm Marina Jurica with NASA's Jet Propulsion Laboratory, and we're live here on Lab in Southern California to tell you a little bit more about the SWOT mission. Now, the SWOT satellite will be observing almost 90% of the water on the Earth's surface for the first time. And the SWOT mission is led by NASA and the French space agency CNES. And here to tell me a little bit more about what SWOT will do and how it will benefit each and every one of us is JPL hydrologist Cedric David. And I'm going to be calling him into this Instagram live right now, so just bear with me as I invite him in. All right, just sent him the invitation. And there he is. Hello, Cedric. Can you hear me?
Yes. Hi. Are we live? This is it?
We are live. This is it. Well, Cedric, thank you so much for joining us today.
Well, thanks for having me. And hello, everyone out there on the internet. Thank you for joining us for the SWOT revolution.
All right. So tell me a little bit about where you're joining us from today.
So I'm currently standing in the Von Karman Auditorium at NASA's Jet Propulsion Laboratory in Pasadena, California. And I'm standing right in front of a miniaturized model right here of the SWOT spacecraft that is 3 times smaller than the real deal and that has none of the bells and whistles of what we'll be launching into space next week.
And I wanted to thank so many people who are joining us. I can see a lot of people are starting to sign in, and I'm very happy to see everybody getting excited about this very unique mission. So tell us, Cedric, what SWOT stands for and also what it's going to do to benefit the work that you do as a hydrologist.
So SWOT is SWOT. It stands for Surface, Water, and Ocean Topography. It's a new space mission. Will be launching next week, and it will be observing all of the waters on Earth, 90% of the waters on Earth, on 2 sides, in the ocean and on the land. And what we'll do is we'll be seeing where water is and how high it is, and from that we can know where it's going. It's really incredible. In the ocean, we'll be continuing 30 years of observations of sea levels, but doing that in such a much finer way that we'll be able to better understand ocean currents. And that's really important for things like navigation, for example. Now on land, on the continents, and that's really what I do on an everyday basis that I'm really excited about, we'll be looking at rivers, lakes, reservoirs, so we'll know where they are, how high they are, and how much water is flowing, which means that we will know the changes in the volume of water, the storage, how much water we have on continents in those water bodies, but we also know how much water is flowing through them. And that's kind of like taking the pulse on Earth's arteries, because Earth is a living planet. And it's the same thing that when we go to the doctor to take our pulse, we'll be doing that from space for the Earth's rivers with satellites.
And for the first time, Cedric, which is great. And we really need to know about that pulse because we need to know about fresh water to be able to survive. So I'm very excited about this as well, too. Now, what made you want to become a hydrologist? And for folks out there who might be interested in this field, what advice do you have for them?
Well, so I have a thing for water, Marina, but I've always been curious about the environment, just understanding what's happening around us. And what's so great with NASA is that, of course, we go into space, we look in the solar system and beyond. And all that is incredibly exciting and important. But as long as we've been looking, we haven't really found another planet for us to live on, right? So planet Earth remains planet A, and there is no planet B. What this means is that it's very important for us to understand how our planet works. And the way we do that is we ship satellites up in space, and they rotate around the Earth, and they take Earth selfies to help us observe many characteristics of the natural environment that allow us to plan for future generations. It's really, really important.
And also on that same vein, it is an international, truly an international collaboration. So tell us a little bit about everyone who is involved with this SWOT mission and why it plays a little special place in your heart as well.
Yeah, so you're right. This is an international collaboration with hundreds, if not thousands of people, right? And it's just 2 of us talking about it, but so many people have been involved in the mission for many years. And so it's currently an international collaboration between NASA, the French space agency CNES, but also the UK Space Agency and the Canadian Space Agency. So an international collaboration, international effort, kind of like the World Cup, except that at the end, everybody wins because we all understand better about the Earth's water cycle. Now, just so happens that I was born in France, and I've lived in the US for nearly 20 years, and I study the world's rivers. So there are three things about this that connect me to the SWOT mission that makes it kind of a little bit of a match made in heaven for me to play a very small part in a huge mission.
And that international collaboration truly shows that water unites us all, which is really, really amazing. So we've talked a little bit about how SWOT is going to track almost 90% of the water on the Earth's surface. Why is that so critical, not only to us understanding the water on Earth, but for your work as well?
Yeah, so water is very important for me. I have a special connection with water. It's my lifelong friend and my happy place. And I encourage our audience to go look at the video that we recently released on my adventure with water. But now for us all, and I'll focus on the continents because that's my thing. The United Nations tells us that safe access to fresh water for drinking and for sanitation is a human right. Now, if you think about it, on Earth 200 years ago was 1 billion people with a B, right? And now it's more than 8 billion people. The amount of water that we've had on Earth has been the same since the beginning of times. But with more and more people, it's very important to make sure we understand how the water is moving around the Earth as best as possible so that we can ensure safe access to fresh water for everyone on this planet.
That's so important. And earlier you were talking about how there's the spacecraft model right behind you.
That's
so
right.
Tell us a
Yeah.
little bit about what you think is the coolest part of this satellite.
Yeah, Marina, do you like fireworks?
I do.
Okay, I love fireworks, right? It's so exciting. So this spacecraft in real life, it's 30 feet in width. That's about 10 meters, right? It's so big that it doesn't fit in the spacecraft. It doesn't fit in the rocket that we'll be shipping next week. So that means we have to fold it. We have incredible engineers that figured out a way to fold the arms and then attach them with little pyrotechnic devices that are attached to springs. And what we'll do is once we've packed it, put it in the rocket, launched it up in space, we'll be doing the unfolding. And that involves little explosions to release the springs so that the arms can open up and be as big as they need to be. So space pyrotechnics, space fireworks, I think it is just so cool.
It is. And before we get to do all of that unfolding, we've actually got to launch the spacecraft next week. Actually, really close to where we are right now, Cedric. So where are you going to be for that big launch day next week?
Well, if all goes well, I will be at the base in Vandenberg next week to be able to say bon voyage to the spacecraft and wish it a safe journey up and away to space. Say go SWOT.
And so I know that a lot of your science will be, of course, after it launches, but is there anything, butterflies in your stomach? Is there anything that you are thinking of now as we're just 1 week away from launch?
I think it's butterflies in everybody's stomachs, Marina. It's as I mentioned earlier, it's hundreds, if not thousands, of people who have been working on this mission for many of them much longer than I have. It's been 20 years in the making, and so every one of us has been working very hard to make sure that everything goes as planned. And when finally we'll get the observations, the data that we've been looking for, that'll be something special. But first things first, let's make sure that it goes there and that everything goes well next week.
Yes, we have definitely all got our fingers crossed to make sure that it goes off without a hitch next week. Well, thank you so much, Cedric, for joining us today. We appreciate it so much.
Thanks for having
good
me.
luck with the launch next week at Vandenberg. And thank you so much for everything that you do for SWOT.
Appreciate it.
All right, thanks so much, Cedric. That was so great. I know that you have a lot of questions about SWOT. So if you want to learn more about this mission, then make sure to follow at NASA JPL as well as at NASA Climate Change to learn more about the mission. And NASA on its YouTube channel will be broadcasting the launch live from Vandenberg Air Space Base next week on December the 15th. And that launch broadcast is going to start at 3 o'clock in the the morning Pacific Standard Time. So make sure to get the coffee ready. And we want to hear from you. If you want to ask questions, we might be able to answer it live on that broadcast. So make sure that you tune in and use the hashtag #TrackingWorldWater so that we're able to answer those questions live. And we're going to be talking to a few more SWOT mission members. So make sure to tune in next month, January in 2023, for more on this incredible mission. And remember, at NASA Earth Science, your home is our mission. Thanks so much for watching, and go SWOT!